Hello, everyone. I'm Vivek. Today, in this session, I will be presenting load balancer as a service deployment architecture at eBay, and like what we implemented at eBay to take LBaaS to next level. So, along with me, Vijay helped me a lot towards this journey. He could not make it to Paris, but we both worked on this solution. So, a little bit about eBay. eBay and PayPal and other subsidiaries, they have over 300 million users, and they drive big traffic to eBay. Most of this traffic is served by eBay Cloud, and part of eBay Cloud is run by OpenStack. So, yeah, that's where we come into picture, and I work on LB solution of that OpenStack Cloud. So the agenda for my presentation is we'll go over the multi-region, multi-VPC architecture of LBaaS and eBay Cloud, and then we have implemented SSL APIs on top of default OpenStack LBaaS. So we'll discuss about that, and we have also implemented brand new Horizon UI for LBaaS. So we'll have a demo, cool demo for that, and we had integrated hardware LB device with OpenStack Cloud. So I will just briefly go over that. And then this is very important for DR capability. We implemented global load balancing solution in eBay to tackle DR related issues where one region goes out, then traffic can route to other regions. We'll discuss a little bit about LBaaS agent, HA, making how automated that, and advanced scheduling algorithms we implemented, and Designate integration. So, cloud at eBay. As you can see, we have multiple regions for DR. Each region is running its own cloud instance. At region level, we run Keystone and Glance for identity management. And then in each region, we have multiple availability zones. Each zone contains OpenStack controller, networking, storage, and compute. And then we have Nova cells. This is our distributed architecture of OpenStack Cloud. LBaaS. So this is one AZ level view for LBaaS. We have a Neutron controller. Each Neutron controller has a LBaaS driver for a vendor, and then multiple LBaaS agents register themselves to LBaaS driver. Each LBaaS agent represents LB pair. So each LBaaS agent manages a LB pair like this. So if we have like 10 LB pairs, there will be 10 LBaaS agents talking to LBaaS driver. And everything runs in HA. So there are multiple Neutron controllers running in active-active, which means LBaaS drivers are running in active-active config. LBaaS agents, however, are running in active standby config. So we do health check using pacemaker, and if something goes out, if some LBaaS agent dies, then the other LBaaS agent will detect the failure and take over the management of LB device. SSL handling. So the out-of-the-box LBaaS driver does not have SSL APIs. And that's a key feature we needed at eBay because we run everything or most of the production stuff on HTTPS, and SSL was a key requirement. So to overcome this, we implemented SSL APIs we are running Havana Cloud. So we implemented in Havana, and also be ported it to Icehouse. These APIs provide capability to create, delete, search, associate them, unassociate them from LB webs. So I will briefly go over what APIs. We also implemented Neutron CLI for those APIs, and it is all being pushed upstream. I will briefly go over the action, the sequence we need to perform the operations. Neutron, first will create SSL certificate. You call LB cert create. with the name, passphrase, and paste the entire certificate. I just did dash dash because certificate was too long, but that's where the certificate goes. Then it's just like any other Neutron entity. You can do list and show, and you will see the certificate. After certificate is created, you also have to create certificate chain. If it's optional though, if you have certificate chain, you can go ahead and create using this similar command, SSL cert chain create, and then again do a list or show on that. Then we have SSL cert key creation. Similar steps, do SSL cert key create and then show. It will show the key. So once all these three entities are there, we need to bind them with the web. So for associating them with the web, there is an association command, LBaaS web SSL cert associate, where you pass the association name and the cert ID, the key ID, and the chain ID. So with that, it will create association. It will tie the certificate with the web, and that's how you use it. As you can see, all these entities, key, cert, and chain, they are independent, so they can be mixed and matched with different associations. So for tearing it down, you first need to disassociate it from the web. Once it is disassociated, and if the cert is no longer used, you can call SSL cert delete API. If cert is being used, it will perform validation and it will deny deletion. Same thing goes with cert chain and the key. So here are the pointers. You can refer to these links, and you can. Everything is open source. We have proposed it back to community for backporting. So if you're running Havana or iSauce and you need SSL API support, you can backport it. Feel free to. And there is a documentation you can refer to. And yeah. So next up is Horizon UI. As I told you, the default LBaaS UI didn't scale, and it was not very intuitive. So we decided to go ahead and implement Horizon UI ourselves. So this Horizon UI, we made it much like launching an instance in OpenStack. It's very intuitive, and yeah, and it also includes the SSL part which we implemented. So I will just show you a demo in the next slide. Okay, so we'll first see a list of all the instances. I had 2 instances under my tenant. Now, these instances can be made member under load balancer. So we introduced this load balancer tab. It opens our landing page, where we can see all the LBs created so far, and it will show most of the config information, what protocol it is using, what port it is running on, what is the IP, and monitor. Now we click on launch a new load balancer. We can go and pick any old existing IP and on a different port, or we can just choose to create a brand new IP, and this LBaaS will select an IP for you from Neutron. Okay, so let's go and create a new IP. We can give it some name, and this name will also become a FQDN for your LB. So I will show you it in the end after the creation is done. You can select the load balancing algorithm, round robin, list, collection, all what comes default. You can choose the instance port where your service will be running, protocol. And so if you select HTTPS protocol, it enables you to provide SSL certificates. You can choose a common certificate, which is a wildcard certificate specific to our deployment, or you can specify your own certificate. For now, I will keep it empty. You can specify monitor, TCP, HTTP, or enhanced monitor, advanced monitor, ECV, where you can specify interval, timeouts, send string, and receive string. So in this example, I'm saying do a get on health check URI, and if it returns success, assume that the member is up and running. And then instances, it will, as we saw in the first slide, I had 2 members, so it will only show me members which are part of my tenant. I can add, remove members from this UI, very easy. I can even search members. Now I will say launch, and since I have not provided SSL certificate, this should give me an error. Yeah, so this does validation, and it says you have selected HTTPS protocol, you have to provide SSL certificates. So I will change it back to non-HTTP just for the sake of demo. Give it a name. Yeah, we'll check the values again in all tabs. So this is just like creating a Nova instance. And launch. Okay, so it takes few seconds, and it appears here. You can see the entry. It got an IP, brand new IP with the port you selected. It got a DNS FQDN. It shows the instance member port. And you can click on this to get more details about this LB instance. It will show you the UUID. It shows you the DNS name, which it created for you. By the way, this is pingable. So shows the algorithm. It shows the members which are part of this LB. Yeah. Okay. So now you can take multiple actions on this LB. You can terminate it, or you can enable, disable it. We are adding more actions. This can be appended to it. And you can edit most of the values for this LB. Like you can change the load balancing algorithm. You can change the ports. You can change the health monitor. You can add, remove members. If you have more members you want to add behind this load balancer, you can do that. I'll just show you an example here. Yeah, so cancel it. Yeah, so that concludes my demo for Horizon UI. So we'll move on to the next items. Yeah, so I forgot to mention that. So now we added this member, and let's say someone terminates this member from Nova instance. We have also added a listener in the backend. So since this member is part of an LB, LB will detect a deletion of, listen to that Nova instance deletion, and it will remove that member from LB automatically, so that user don't have to. Okay. So next slide. So here, this is how our wiring is. How are we integrating hardware LBs with the overall network? So we have Neutron and LBaaS driver sitting on a controller outside the cloud. They talk to LBaaS agent, which is again sitting outside the cloud. LBaaS agent talks to or manages an LB pair, which is a hardware LB pair in this example. It is also sitting outside the cloud. And then from LB, we have static routes created for the SDN gateway. That's where we get entry inside the cloud. So all the members are sitting inside the cloud. LB knows how to reach to those members using static routes, and that's how it does the routing. So it does some SNAT and then reach the members and gets a response back from member and then send it back to the web. Yeah. Okay, so global load balancing. This is a big deal for us because we wanted our applications to be available across the regions. The limitation with cloud is that it can only live, the scope is limited to a region. So you see 3 regions in this diagram. All three are 3 different cloud instances. Now, what we did to make it globally available is we added a global load balancer on top of it. Now, what this does is, for same application, let's take an example, www.ebay.com. We can run that ebay.com web service on all 3 clouds. We can have LB, load balancer webs in all 3 clouds for ebay.com. Next, what we can do is to add these webs on the global load balancer. So global load balancer does a health check on all the regional webs, and if any regional web is down, it will just slash it off from the serving traffic. So when client requests to go to ebay.com, the first request will go to global load balancer, which also act as the DNS resolver. The DNS resolver will respond back with all the active webs in the region. And then client can make a choice to use any of the IP he wants, which all of them should be available at that time. So client makes a call to any of the region, but if that region has to go down, global load balancer will detect that failure and it will not respond that IP anymore. So that's how we are achieving global load balancing. How are we integrating with C3 is like this. By C3, I mean our cloud. It's a eBay cloud. We call it C3. It's based on OpenStack. So tenant goes to, so by the way, we are running a global keystone. So one tenant can use the same credentials to log in to different regional clouds. So once tenant logs into region 1 cloud, he can go and create a LB instance first for ebay.com. And then in the same region, he can go to GLB page where he put that LB instance as part of GLB wide IP. Once that GLB member is added, the same tenant can go to another regional cloud and do the same steps, create a LB for application running in that region, and then add that LB to GLB. So by this, ultimately, by doing this, he will achieve this this model where all the LB webs are part of global load balancer, and now health checks are performed across the regions, and traffic is distributed across the region. Okay. All right. So we also implemented advanced scheduling algorithms to cater different needs. LB selection is done based on two-stage LB scheduler we implemented. The factors are VPC, what VPC tenant is coming from, what kind of SLA they are requiring, what is the fault domain, is it production or non-production workload, who is the vendor for the LB, how loaded are LB, and do we need to, so we does statistics of LBs and see how loaded LBs are and decide which LB will get next web provision on it. And dedicated versus shared LB, if tenant does not want to share their network bandwidth with any other tenants, they want isolation, they can choose to have dedicated load balancer. So based on all these factors, we decide, our scheduler decide where and how to provision the webs or the load balancer. So we'll see a diagram again. This is the AZ level neutron controller. So when client makes a call for LBaaS through API or through CLI or through UI, request comes to Neutron. Neutron passes it to first level scheduler. In that, it will first determine what vendor to choose based on requirements, based on user inputs. So we may have multiple drivers, which each signify different vendor. Each driver has its own scheduler, which will further drill down and see what are the health of all the LBs, hardware LB or virtual appliance running, and how loaded they are. So it will choose what LB to pick for. Then it makes a call. Either it will go to LB1, LB2, depending on its scheduling algorithm, or it can post a message to agent level. It's a different architecture where we have agent also. There are some with agentless, and there are agent-specific drivers. So it will delegate it to agent, and agents will then provision it to LBs. Okay, and at last, I think this is the last slide. To take it to next level, we also integrated LBaaS with Designate. Designate is a DNS as a service for OpenStack. We were the early adopters, and we integrated load balancer service in eBay with Designate. So when LBaaS webs are created or removed, it emits a notification targeted towards Designate, and Designate has a handler to consume such notifications. Once those notifications are being received by Designate, it will it will create FQDN or remove FQDN based on user settings. Yeah, so that concludes my presentation. If you have any questions, you can feel free to contact me at vivekjain@ebay.com. Thank you.